blows. I hope I didn't break this thing. Mess up my CD. Man, where's that coming from? Ah, the old sun, eh? What is it?
It's a perfect balance of gravity and pressure.
What does that mean?
Let's start at the beginning. Right before a star with high mass dies, it becomes unstable and explodes, which is known as a supernova. This supernova releases a wave of energy.
Like the ripple in a pond after throwing a rock into it?
Just like that. Now if this ripple reaches a group of leaves, what happens to them?
They are moved.
Right. They clump together in groups. Well, in space, the star's explosion acts as the rock. The various gases, which make up the interstellar medium, act as the leaves.
Okay, but what's an interstellar medium?
The interstellar medium is a compilation of substances that compose part of the space between stars.
Ah, so that's kinda like water.
And the wave of water is just like the wave of energy from a supernova.
But what are the clumps of gas really?
Ah, the clumps are the possibilities of stars.
What do you mean?
You see, these clumps are actually molecular gas clouds. Since gravity naturally attracts matter to the densest regions, the cloud separates into different dense areas.
Like a bunch of little magnets that get close to each other and are pulled into each other. And so it gets stronger and more magnets are attracted to them.
It is very similar to that. But if there is less than 0.08 times the mass of the Sun, this now dense matter will not be able to form into a star because it will not be able to fuse. Likewise, if there is more than 100 times the mass of the Sun, there will be too much mass to form into a star because the pressure that it will create will become too strong for fusion to occur.
Fusion?
We'll come back to that.
Okay. Wait, is that when a star is made?
Not yet. This process of mostly hydrogen gases coming together due to gravitational pressure also creates another type of pressure.
Another type of pressure?
Yes. Just keep in mind that for every action, there is an equal and opposite reaction.
Isaac Newton's third law.
Very good. The gas molecules are constantly moving and are now getting closer together because of the gravitational pressure. This causes the particles to get closer to each other and therefore create heat or thermal energy. This causes thermal pressure.
Crazy.
Very. Now in the beginning of this process, it is somewhat easy for the thermal energy to escape the center, but as the center becomes denser, this becomes more difficult. This is because gravitational energy becomes stronger and traps the energy in the center.
Whoa, so where does all that thermal energy go?
It gets trapped and creates more thermal energy, which makes the pressure build up even more.
And then it's a star?
Almost. It is now known as a protostar. It will go through a stage of growth because when the core of a protostar, or even a star, becomes hotter, it shrinks. Now the protostar is heated through convection.
I don't really understand it. Like the oven?
Yes. Think of a protostar, or even a star, as the CD in your hand. They both have many layers to them which perform different actions. First there is the center, or core. This is the densest and hottest region. Then there is a middle layer of gas, and finally the outer shell, which is what we see as the visible surface.
So what's the difference between a protostar and a real star then?
The core is not hot enough yet for fusion to occur efficiently in the protostar. For it to be a real star, its main release of energy must come from radiative diffusion.
What's that radiative diffusion?
It is the process by which photons, or light particles, gradually move from the hotter regions, like the core, to the cooler ones, like the surface. They are then released as light.
And the fusion stuff?
One more minute. As the interior of the protostar heats up, the energy can move easier, and radiative diffusion takes over from convection. Once the core of the protostar becomes hotter than 10 million degrees Kelvin, it will then be hot enough and stable enough for fusion to occur. The new star's interior structure stabilizes because the energy produced in the core matches the amount radiated from its surface.
Fusion!
Fusion is basically when two particles have enough energy to bind themselves together. In the case of this star, the hydrogen molecules will become excited enough to fuse into helium, which subsequently releases energy.
Holy shyster!
Yup.
So then it just sits there forever?
Well, to us humans, it may seem like that, but a star can usually live anywhere from about 14 million years to about 14 billion years.
But it can't fuse forever because there's only so much hydrogen in the core, right?
Yes. Once hydrogen fusion is exhausted and only helium remains in the core, the star begins its death process.
Oh man.
Do not fret. This process can take millions to billions of years.
Oh man.
Once helium is all that remains in the core, it contracts because the thermal pressure drops and the gravitational pressure becomes stronger.
Which makes the shell thing get bigger.
But it will eventually become hot enough again for fusion to occur, which will create more pressure.
And make the core grow again and make the shell shrink again.
Right. But not back to its original size. The core will also become hot enough to make another layer of hydrogen gas fuse into helium.
Okay. So, what does the helium fuse into?
Carbon.
And then the same thing happens. The carbon is all fused up, so the core shrinks, which makes the shell grow.
Exactly. But this is the final chance at fusion for this star. It is now known as a red giant. This is where the growing and shrinking process ceases because the core will not become hot enough to fuse carbon.
And then it explodes?
Not exactly. Once the core becomes carbon, its pressure is no longer able to balance the pressure of the outside shell. They are expelled into what is called a planetary nebula, which has nothing to do with planets. The carbon core which is left behind is called a white dwarf.
So all stars go through this, right?
Well, not all stars. They are grouped into two basic sets, which are high mass and low mass stars.
Simple enough.
The star which was just described was a low mass star. A high mass star will basically go through the same process, except fusion will not stop at carbon. The carbon will fuse into oxygen, which will fuse into neon, which will fuse into magnesium, which will fuse into silicon, which will finally fuse into iron.
And then it explodes?
Actually, yes. The iron core will not become hot enough for fusion to occur. The star collapses on itself, which causes a violent energy reaction, and the star explodes into a supernova. It leaves behind one of two things, either a neutron star or a black hole.
Which is what causes the wave, which causes the clumps and the protostar, and the whole thing is recycled.
Precisely.
So then there is one thing I really am not getting. What's energy?